estimate the area under the graph of h of x equals x squared plus 5 from x equals -1 to x equals 2 using 6 approximating rectangles using midpoints. All right, so this one's a step up from the others because we've got 6 rectangles instead of 4, and we're also using midpoints. So we're looking at the graph of x squared plus 5. We know that is a parabola that, the standard parabola of x squared, but shifted up 5 units and opening upward. So something like this. I'm just doing a rough sketch. It's probably not going to be perfectly to scale, but I just want an idea of what we're looking at. Now we're going from -1 to 2. So we could say this is -1. We go up. And then maybe this is +1 and this is +2. So we're going up there. And so this is our region, which I am going to shade in because I'm loving these colors. Again, it's not perfect, but much better than no shading at least. Something like that. All right. And we're told we're using 6 approximating rectangles. So if we actually label these, the base of this region, this shape, is currently 3. So if we want to divide it into 6, we're actually dividing into strips with width 1/2. So this is 1/2, that's 3/2, this is -1/2. And these are going to be the strips that we are chopping this region up into. And then we are using approximating rectangles with midpoints. So what that means is for each of these strips, I'm going to start with the one on the right, just because it's a little bit easiest for me. We're taking the midpoint. So the height of the rectangle, we're not doing a left approximating rectangle from the left side, and we're not doing a right side. We're actually taking the midpoint, and we're going to go up and see where we hit that graph, and that is what we're going to use for the height of that rectangle. So it's going to be something like that. And then similarly, for the next one over, we're going to be using the midpoint, and I can even mark these on the bottom. We're using the midpoints of each of these, and we're using the function value at that midpoint to get the height of that rectangle. And then we've got 2 more on the left side. It's going to be something like that. Okay. I know it looks a little bit different, a little bit more difficult, a little bit more complicated, but it's fine when we're doing the calculations. It's not that much harder. We just got to be a little bit more careful. We're going to use midpoints instead of left or right, so I'm going to call that M, and we've got 6 of them, so we're going to call it M sub 6. Now the base of each of these strips is 1/2 unit, and we know that because we've got a width of 3, and we're dividing it into 6 equal strips, and so 3 divided by 6 is 3/6 or 1/2. So the width of each of those rectangles is 1/2. And then the heights of them are going to be this function evaluated at all of these midpoints. The function is x squared plus 5. So let's figure out what these midpoints are. The midpoint between -1/2 and -1 is -3/4. So that first one is going to be -3/4 squared plus 5. Remember, we're taking the midpoint as our x value, which in this case is -3/4, and we're plugging it into x in our function to figure out the height. So we're plugging in -3/4 for x. So it's -3/4 squared plus 5. That's the first one. And then plus the next one, this midpoint halfway between 0 and -1/2 is -1/4. So when we plug that in, that's negative 1/4 squared plus 5. And then we keep going with the other midpoints. We've got 1/4 and then 3/4. So we've got 1/4 squared plus 5. We've got 3/4 squared plus 5. And then the other ones, halfway between 1 and 3/2 is going to be 5/4. That's 1 1/4. So that's going to be, 5/4 squared plus 5. And then the last one is 7/4. So 7/4 squared plus 5. I realize I'm running out of room. And again, I am just using a calculator here to do all this arithmetic. I don't want to do it by hand. I end up getting 287/16, which is equal to 17.9375. And I'm just going to tell you, if you were to go through and take the limit as the number of strips goes to infinity to get the actual area, you would end up with an actual answer of 18. And so this midpoint approximation is actually a very, very good approximation. So in this case, using 6 rectangles and midpoints actually got us only 1/16 away from the actual answer. So it's actually a pretty useful way even to get approximations. Though, of course, we know the goal is to get the actual area, which involves taking a limit, but even these approximations can be pretty good.